I am physicist Abelgas.
I am physicist Procolo.
I am physicist Ong, and we're here to present our physics experiment.
Our physics experiment involves law of acceleration as well as conservation of energy.
Come and join us to see the beauty of physics.
As what physicist Abelgas said, our experiment demonstrates the law of conservation of energy and Newton's second law of motion, the law of acceleration. But we'll be focusing more on collisions, and we'll check if the collision of objects is elastic or inelastic. We'll also calculate to see if momentum and kinetic energy were conserved throughout the collisions.
The materials we need for our experiment are 3 marbles, 2 bigger same size marbles, and 1 that is smaller. The 2 different size marbles need to be weighed because we'll be needing the mass. We need 2 straight objects and a measuring instrument. You may use 2 meter sticks. In our experiment, we use 2 straight wood for the straight objects and a T-square for the measuring instrument. We'll also need a table as the base as well as a stopwatch. You may use tape to hold the straight objects in place, but it is not required. The straight objects must be placed parallel to each other and should have just enough space in between for the marbles to pass through. The measuring instrument and the stopwatch are used to calculate the velocity of the rolling marbles. We conducted 4 different trials making marbles collide with each other in between the 2 straight objects, and we measured the distance and time that the marbles moved before and after they collided. By dividing the distance by time, we were able to get the velocity of the marbles.
Aside from velocity, we have 2 other equations that we need to use. The first equation is used to determine the elastic and inelastic collision in terms of the conservation of momentum and to calculate the change of momentum in the marbles. This is called the conservation of momentum, which is a fundamental law of physics that states that momentum of a system is constant. If there are no external force acting on the system, momentum is conserved in both elastic and inelastic collision. The second equation is just simply used to prove that an elastic collision is truly an elastic collision. This is called the conservation of kinetic energy. We can prove that an elastic collision is elastic by finding out if the kinetic energy of the colliding object was conserved or not. Kinetic energy is conserved in elastic collision, while in an elastic collision, kinetic energy is not conserved. In experiment 1, we used 2 marbles of the same mass. One marble was at rest, while the other one was rolled toward the resting marble.
After the collision, marble B was no longer at rest, while marble A had a slower velocity after the collision. From the calculations of the results in experiment 1, we can say that the momentum was conserved with a 0.01 margin of error. Kinetic energy was also conserved with a 0.015 margin of error. However, the values for the conservation of kinetic energy were not close to equal. From this, we can assume that the collision of marble A and B is inelastic.
In experiment 2, we used 2 marbles of the same mass again. This time, both of the marbles were moving toward each other.
The result was an opposite reaction after their collision. Their velocities were slower after the collision. Momentum was conserved with a 0.06 margin of error. It is difficult to determine if momentum was truly conserved since the value difference is large. Kinetic energy, however, was conserved with only a 0.009 margin of error, and the values for kinetic energy conservation are close to equal, especially if rounded off to the second decimal place. From this, we can say that this was elastic.
Experiment 3 is similar with experiment 1. One marble was resting and the other was rolling towards the resting marble, but this time we're using 2 marbles with different mass, the rolling marble being smaller than the one at rest.
This experiment demonstrated the law of acceleration the best. Due to the difference in mass, the bigger marble had a slower final velocity after being collided by the smaller marble. Momentum conservation had a 0.007 margin of error. Again, it was hard to determine if momentum was really conserved because the final values were not close to equal. Though kinetic energy conservation had a minute margin of error, the final values were also not close to equal. Therefore, we can say that the collision of marble A and marble B was inelastic, which was to be expected because of the mass difference.
In experiment 4, all 3 marbles were used. 2 marbles of the same mass were rolled toward the third marbles that had a different mass, and these marbles was at rest.
Marbles A and B were moving together before they collided with marble C. After the collision, marble A and B moved at slower velocities, and marble C was now in motion. Marble A, however, got left behind by marble B and C as they continued to roll out of the table or base. From the math, momentum was definitely conserved with a 0.005 margin of error and close to equal values for the equation. But because the final value for the conservation of kinetic energy are not equal, the collision of marbles A, B, and C are therefore inelastic. It was difficult to determine if momentum and kinetic energy were really conserved because majority of the math did not give an absolute indication that momentum and kinetic energy were conserved, with a few exceptions. It was also difficult to indicate which collisions were elastic or inelastic, not only because the math did not give an absolute indication, but also because the collisions were in the middle of being elastic and inelastic, which was to be expected. Reasons such as human errors in calculating the velocities and external factors like friction, air resistance, gravity, and an incline on the base could be reasons as to why the results were inconsistent. As an overall conclusion, 3 out of 4 of the collisions were inelastic, and only the second trial had an elastic collision. Therefore, kinetic energy was only conserved in the collision of the second trial. Minus the external factors and minor errors and inconsistencies, momentum was also conserved for all of the trials, both in elastic and inelastic collisions.
Thank you for watching.
We hope you learned something new today.
And we also hope that you are able to gather newfound appreciation for physics. Goodbye.